You ever just stop and wonder how an app on your phone, one that started small, can suddenly handle millions of users at the same time without just blowing up? It's not magic, that's for sure. It's actually a really cool engineering journey. And today, we're going to walk through that exact journey, step by step, using some awesome insights from Alex Hu's book, System Design Interview. We're going to peel back the curtain and see how these massive systems are built from the ground up. Ready? Let's dive in. So yeah, that's the big question, right? How do you go from one user to millions? It's this incredible journey from like a single idea on one lonely computer to this massive global system. And you know what? It always starts super simple. And I mean really simple. Believe it or not, pretty much every massive service you use today started right here. Just one server. That single box is doing everything. It's the web server, it's the database, it's the whole brain of the operation. And for your very first user, or your first 100 users, this is totally fine. It's simple, it's cheap, and hey, it gets the job done. But of course, the goal isn't to stay there. The goal is to get from that one little box to this, a massive, globe-spanning network. We're talking data centers, caches, servers, all humming along perfectly together. That huge leap from point A to point B, that's what scaling is all about. So, let's trace that path. Let's see how you actually get there. Okay, so this is where you hit your first real growing pains. Your app's taking off, people love it, they're signing up, and that single server of yours, it's starting to feel the heat. It's sweating. Things are slowing down, and you get that sinking feeling that if you don't do something and do it fast, the whole thing's gonna crash. So what's the first move? It's a classic. Divide and conquer. You take that all-in-one box and you split it. You pull out the database, the part that stores all the data, and put it on its own server. So now you've got the web server that talks to users and a separate database server. This is huge because now you can upgrade each piece on its own. If the website's slow, you upgrade that server. If the database is slow, you upgrade that server. You're no longer stuck with one giant bottleneck. And right away, this split brings you to a major crossroads. You have to decide how you're going to scale. Are you going to scale up or scale out? Scaling up, that's vertical scaling. Think of it like swapping out your car's engine for a much bigger, more powerful one. It's pretty straightforward, right? But there's a limit. You can only make an engine so big. Scaling out, on the other hand, that's horizontal. Instead of a bigger engine, you just add more cars to your fleet. It's a bit more complex to manage all those cars, for sure, but this is the absolute foundation for building huge applications. Why? Because you can theoretically keep adding cars forever. All right, so you've decided to scale out. You've got a whole fleet of web servers ready to go. But this creates a brand new problem. What happens when a massive wave of traffic hits you all at once? How do you manage that chaos and keep everything from just collapsing? Think about it. You've got all these servers, but all your users are still knocking on the same front door. How in the world do you spread them out evenly across all your new machines? And maybe even more importantly, what happens if one of those servers fails? You don't want the whole system to go down with it, right? Well, the answer is a really clever piece of tech called a load balancer. This thing is the hero of our story right now. It's like the gatekeeper, or maybe a super efficient traffic cop for your whole system. Its one and only job is to look at all the incoming traffic and smartly decide where to send it. And you can see exactly how that traffic cop works right here. The load balancer just sits out front in front of all your web servers. When a new user shows up, it takes a look and says, okay, server 1 looks a little busy. Let's send you over to server 2. And what if server 3 just completely crashes? No big deal. The load balancer sees it's down and just stops sending anyone there. Just like that, you've gotten rid of a massive single point of failure. Your app is suddenly way more reliable. Okay, progress. Our web servers are safe from being overwhelmed. But in system design, when you fix one bottleneck, you almost always find the next one. And that's exactly what's happened. All our web servers are now hammering our poor single database with requests to read data, fetching profiles, loading posts, all that stuff. And that one database, it just can't keep up. So what do? Well, if one database can't handle all the work, why not get it some help? It's a pretty simple idea, really. It's called database replication. You just create a bunch of copies, or replicas, of your database, and you spread the work across all of them. And here's how that works. It's actually a pretty clever system. You pick one database to be the master, or primary. This is the only one that's allowed to handle writes. Things like someone creating a new account or posting a photo. Then, that master database automatically copies any new data over to a bunch of slave or replica databases. And what do they do? Their only job is to handle the massive fire hose of read requests. It's a perfect separation of duties. And this one change? It gives you this incredible trifecta of benefits. First, your performance goes way up because reading data and writing data aren't tripping over each other anymore. Second, you get way better reliability. Your data now exists in multiple places, so if one server's hard drive dies, it's not a catastrophe. And finally, you get high availability. If one of those read databases goes offline, the others just pick up the slack, and your users probably never even notice. So at this point, our system is pretty solid. It's reliable, it's available, but is it fast? The next big leap in scaling is moving beyond just trying to stay online. Now we're focused on the user experience. We need to make things snappy and cut down those load times. And for that, we bring in our next tool, the cache. The best way to think about a cache is like your system's super fast short-term memory. See, even a highly optimized database is still kind of slow compared to memory. A cache is a layer of that super fast memory that sits right in front of the database. It just remembers the answers to frequently asked questions so you don't have to bother the slow database every single time. So let's walk through how that works. A user asks for some data. The first thing the web server does is check the cache. Hey, cache, do you have this? If the answer is yes, we call that a cache hit. Bam! The data is returned instantly. Super fast. If the answer is no, a cache miss, then okay, no problem. The server goes and gets the data from the database like it normally would. But here's the clever part. On its way back to the user, it drops a copy of that data into the cache. That way, the next time somebody asks for it, it'll be a super fast cache hit. So caching is amazing for data that changes, dynamic stuff. But what about all the files that don't change? I'm talking about images, videos, all the code files that make the website look the way it does. For all of that static stuff, we use something even cooler, a content delivery network, or a CDN. So what's a CDN? Just think of it as a huge network of servers, strategically placed all over the globe, and their only job is to store copies of your static files. So let's say your main servers are in Virginia, but someone in London wants to see a photo on your site. Instead of that request having to travel all the way across the Atlantic and back, the CDN serves that photo from a server that's right there in London. The distance is way shorter, and since the speed of light is, a constant, the file gets there incredibly fast. For a global app, this isn't just nice to have, it's an absolute game changer. All right, things are looking really good now. We've built a service that's not just reliable, but it's fast for users everywhere. So what's left? Well, it's time for the final boss level of scaling, building a system that's so resilient it can survive an entire data center going offline. To pull this off, we need to make one final, really important architectural shift. We have to make our web servers stateless. Now, what does that mean? Well, think about it like this. A stateful server is like going to a bank where only one specific teller, Bob, knows your account details. If you want to do anything, you have to talk to Bob. If Bob's on lunch or his line is a mile long, you're just stuck. That's no good. A stateless architecture is like a modern bank. You can walk up to any available teller and they can pull up your info from a central computer and help you. That's exactly what we want for our servers. We pull all the user session data out of the individual web servers and put it in a shared place, like a database or a cache. Now, any request from any user can be handled by any server in our entire global fleet. The flexibility this gives you is just immense. And here it is. This is the grand finale. This is what everything we've talked about builds up to. We've got multiple data centers, say one in Europe and one in Asia. When you visit the site, you're automatically sent to whichever one is closest to you. And inside each of those data centers, you see all the pieces we've put in place: the load balancers, the fleet of stateless web servers, the caches, the replicated databases, all of it duplicated. This, right here, is a system truly built to handle millions and millions of users around the world. And of course, this isn't even the whole story. There are a ton of other tools humming away behind the scenes to make all this possible. You've got things like message queues, which are like a shared to-do list for your system. They handle tasks that don't need to happen immediately, like processing a video you just uploaded, so you're not stuck waiting. Then you have logging and metrics. This is absolutely critical. It's like the system's heart monitor and dashboard, telling engineers exactly what's happening everywhere, all the time, so they can spot problems early. And finally, there's automation. This is the army of scripts and tools that builds, tests, and deploys everything, making sure it all happens consistently and reliably. These are really the unsung heroes of any large-scale system.
So there you have it. We went from one lonely server in a closet to a global powerhouse. But here's the secret. The journey of scaling is never, ever finished. Every time you solve one bottleneck, your service grows, and that growth just shines a spotlight on the next bottleneck. The real art of this kind of engineering is being in that constant cycle of finding the next problem and coming up with a clever way to solve it. The question is never, okay, are we done? It's always, all right, what's going to break next?